Deep in the ocean's embrace, hidden from our view, a cataclysmic event unfolded. A slumbering giant awakened. An underwater volcano, immense and powerful, erupted with unimaginable force. This was not just any eruption, it was the largest ever recorded. The ocean floor, a realm of perpetual darkness, was ripped apart. Molten rocks surged upwards, a fiery torrent in the abyss. The eruption sent shockwaves through the water column, a seismic tremor felt for miles around. This was a spectacle of raw power, a stark reminder of the immense forces that shape our planet. This extraordinary event, though hidden beneath the waves, holds immense scientific significance. The underwater volcanic eruption is not just a spectacle of nature, but a window into the dynamic processes that shape our planet. These eruptions occur at tectonic plate boundaries, where the Earth's crust is thin, allowing magma to escape from the mantle below. It offers us a rare glimpse into the heart of our planet, revealing the intense heat and pressure that drive volcanic activity. Scientists brave the depths, equipped with advanced technology to study these phenomena up close. Their work helps us understand the geological forces at play beneath the ocean floor, a chance to study the forces that drive volcanic activity. By deploying underwater probes and conducting oceanographic expeditions, researchers gather crucial data. This data helps them map the seafloor, measure seismic activity, and monitor the temperature and chemical composition of the water. By analyzing the eruption's aftermath, we can glean insights into the composition of the Earth's mantle and the processes that create new crust. The aftermath of an eruption leaves behind a transformed landscape, rich with minerals and new geological formations. Scientists collect samples from these areas to study the newly formed crust and the materials brought up from the mantle. The eruption also provides valuable data on the chemical composition of the ocean. By sampling the water around the eruption site, scientists can detect changes in its chemistry. These changes can reveal the presence of new minerals and gases released during the eruption. Volcanic eruptions release vast quantities of gases and minerals, altering the chemistry of the surrounding water. These emissions can have far-reaching effects on marine life and oceanic ecosystems. Understanding the types and quantities of gases and minerals released helps scientists predict the potential impact on the environment. Understanding these changes is crucial for comprehending the ocean's role in regulating Earth's climate. The ocean acts as a massive carbon sink, absorbing carbon dioxide from the atmosphere. Changes in ocean chemistry can influence this process, affecting global climate patterns. By studying underwater volcanic activity, scientists gain insights into the complex interactions between the Earth's interior, the ocean, and the atmosphere. The immediate impact of the eruption on marine life is undeniable. The sudden explosion sends shockwaves through the water, disorienting fish and other marine creatures. The once serene underwater landscape is now a chaotic scene of swirling debris and fleeing animals. The eruption not only disrupts the physical environment but also the intricate web of life that has developed over centuries. The blast zone, once teeming with life, is now a scene of devastation. Vibrant coral reefs that provided shelter and food for countless species are reduced to rubble. Fish that once darted through the colorful corals now float lifelessly, victims of the sudden and violent change. The destruction is not just physical, it's an ecological catastrophe that will take years, if not decades, to fully understand. The intense heat, combined with the release of toxic chemicals, has decimated entire ecosystems. The water temperature rises dramatically, making it uninhabitable for many species. Toxic chemicals released during the eruption spread through the water, poisoning marine life and disrupting reproductive cycles. The once thriving ecosystem is now a barren wasteland with only the hardiest of species managing to survive. Creatures that once thrived in these depths have perished, their delicate balance disrupted. The intricate relationships between predators and prey, symbiotic partnerships, and the delicate balance of the food web are all thrown into disarray. The loss of key species can have a cascading effect, leading to further declines in biodiversity and the collapse of the ecosystem. Yet even in the face of such destruction, life finds a way. Slowly but surely, signs of recovery begin to appear. Small fish and other marine organisms start to return to the devastated area, seeking out new niches and opportunities. Algae and other pioneer species begin to colonize the dead coral, laying the groundwork for future growth and regeneration. Marine ecosystems are remarkably resilient. Over time, the damaged reefs will start to recover, and new coral will begin to grow. The return of key species will help to rebuild the complex web of life that once existed. While the process is slow and fraught with challenges, the resilience of marine life offers a glimmer of hope for the future. Organisms from surrounding areas will gradually recolonize the affected region, adapting to the altered conditions. Migration and adaptation are key strategies for survival in the ever-changing marine environment. As new species move in, they bring with them new genetic diversity and the potential for new ecological interactions. New species uniquely suited to this transformed environment may even evolve. The harsh conditions created by the eruption can drive rapid evolutionary changes, leading to the emergence of species that are better adapted to the new environment. This process of natural selection ensures that life continues to thrive, even in the face of seemingly insurmountable challenges. Fire under the sea. Underwater volcanic eruptions, while sharing similarities with their terrestrial counterparts, are governed by a unique set of rules. The immense pressure of the deep ocean, coupled with the presence of water, creates a dramatically different environment. Magma, upon contact with seawater, cools rapidly, forming pillow-like structures. The interaction of molten rock with seawater also generates hydrothermal vents, fissures in the ocean floor that spew superheated mineral-rich water. These vents support unique ecosystems, harboring creatures that thrive in the absence of sunlight, relying instead on chemosynthesis for sustenance. Section 5. Echoes of the Deep. This recent eruption, though unprecedented in recorded history, is but one chapter in a long and tumultuous saga. The ocean's depths conceal a world of geological activity that is both awe-inspiring and terrifying. These underwater volcanoes, often hidden from our view, play a crucial role in shaping the Earth's landscape. Throughout Earth's history, underwater volcanoes have repeatedly reshaped the ocean floor, creating new landmasses and altering coastlines. These volcanic activities are responsible for the formation of underwater mountain ranges and vast oceanic plateaus. The process is continuous, with new land being formed even as we speak. The Hawaiian Islands, for instance, owe their existence to a chain of underwater volcanoes. These islands are the visible peaks of a massive underwater volcanic mountain range that stretches across the Pacific Ocean. Over millions of years, volcanic eruptions have built up these islands layer by layer. The 1883 eruption of Krakatoa, a volcanic island in Indonesia, serves as a stark reminder of the destructive potential of these underwater giants. The explosion was so powerful that it was heard thousands of miles away, and the resulting ash cloud affected global weather patterns for years. The eruption triggered a series of tsunamis that devastated coastal communities, killing tens of thousands of people. These tsunamis traveled across the Indian Ocean, reaching as far as South Africa. The impact of such events highlights the interconnectedness of our planet's geological systems and the far-reaching consequences of underwater volcanic activity. Sentinels of the seafloor. The recent eruption underscores the critical importance of ongoing research and monitoring of underwater volcanoes. By studying these enigmatic giants, we can better understand the forces that shape our planet and the delicate balance of marine ecosystems. Advanced technologies such as underwater remotely operated vehicles and autonomous underwater vehicles allow us to explore these extreme environments in unprecedented detail. These robotic explorers can withstand the immense pressure and darkness of the deep ocean, collecting valuable data and capturing stunning imagery. Our blue planet, our future. The recent underwater volcanic eruption serves as a powerful reminder of the interconnectedness of Earth's systems. Events that transpire in the deepest recesses of our oceans can have far-reaching consequences, influencing our climate, marine life, and even our own existence. As we continue to explore and unravel the mysteries of our planet, we must remember our responsibility to protect it. By investing in oceanographic research and promoting sustainable practices, we can ensure a healthy future for our blue planet and all its inhabitants.